Okay. Dear Streaming Santa, I've been a good CTO at Zender TV, and I wish you could bring me the perfect low latency solution. Love, Patrick. So you guessed my name. There's obviously a definition of good, which you can see here. I haven't been that good, but at least I've done my research. There's a lot of stuff happening in the low latency sector, and obviously, when you went to NAB or IBC, everybody has their low latency, and they throw everything at you if you need it. The reason why we needed it as a company, we provide an interactivity layer on top of live streams, so think trivia games, gambling, and all that stuff. But we don't want to mess with the low latency streaming CDN part. So that's why I did the research and went through the different solutions that I found. So I will not say a specific vendor name, because they're all struggling, they're all new, and everybody's trying to do their best. So this was the first feeling when I was looking at that, really excited, I'm sure everybody who had the low latency demo had to do the wave test and see the latency of actual happening on the screen. So all the vendors will hit you with latency, 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 latency. And obviously, that's really important. And they would typically say, well, we can do ultra-low latency, below sub-second, and so on. La, 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 la. And that's not what we experience. So my talk will be a little bit more on having it run in production, having it tested, and things we hit there. On the different solutions, there's a couple of them that allow you to run your own ultra-low latency solution, but most of them are actually SaaS solution, and they kind of build their own solution. They're often tied to a specific player that solves the low latency solution with a specific CDN and so a specific vendor that you sell. There's no generic player like we have for HLS and so on that you can just put at that solution. It is a very close solution, which is typically because they're first trying it internally, they build their own protocols, and hopefully someday a protocol will emerge. There's a couple of them who try to standardize on WebRTC. There's some who do some fragmented parts on HLS. There are others trying to build their own protocol, and then they mix that into a WebSocket to kind of make the controlling signal for anything happening on top of that. So I know there's a few of them coming out, which is a player who should be CDN agnostic, which is really nice, but it isn't there yet. The whole thing of the fragmented part, they're streaming, but there is no native like iOS and Android player yet, so everybody's kind of struggling to make that happening. First part you need to do is the ingest. From experience, everybody shows you the player, but nobody really tells you how to do a good ingest. Because the ingest is important, having the correct tuning parameters, the bitrate is important, whatever settings you put on your codec, RTMP offset between audio and video, so they all kind of have an impact on the latency. And even having different, doing portrait, landscape, all that stuff, everybody's kind of thinking, yeah, but it's an image, but there's a lot of tuning we found to be done to get it actually from on an RTMP level ingest, which most of them use, to somewhere between that range of 2-3 seconds. We've never been able to go much lower with a good stability than that number. There are other ways, like WebRTC ingest directly from a browser or that kind of style. They can go lower. So most of the demos are actually within a browser, within an application. But if you really use the RTMP, this is kind of like 2-3 seconds to get it reliable with enough buffering, not too much buffering, and all that part. Like I mentioned before, they give you an SDK. Most of them have the SDK for iOS and Android. There's a few out there that will allow you to do it on a set-top box or Apple TV, but most of them are just Android and iOS and web. One of the interesting parts is that for some reason, the video players of the SDKs are huge, like 100 megabytes that you have to put for a player in your app. I don't know where it comes from, but most of them vary between 60 and 100 megabytes to put in your app. So if you have an existing app that's bigger and bigger and bigger, so it's something to watch out for. Then on a compatibility level, they usually say, well, we support everything. And then when you start digging deeper, they say, well, it's Android 4.4, because that was the media version. iOS, the web RTC guys, I would probably say, well, iOS 10, 11 is what better for us. Otherwise, we still have to go with our proprietary WebRTC stack. And the one thing that stands out, depending on your use case, is whether you want to support mobile Safari. As far as I know, there was only one vendor who was able to support that out of the box. And the reason is because Apple didn't really get the encoding part on the Safari or disclose the part. And most of the vendors are not able to do the ultra-low latency support within a mobile Safari viewer. It does work in their native SDK on the app, but if that's your use case, you really want to have low-friction web instant playback, you really have to watch out that you're able to support that. That's probably going to get better, because the new Safari will get WebRTC and no protocols, but that was one of the things you have to look at. It is still amazing that you get just zip files. You cannot just download things. You have to, in part of the developer ecosystem, it is really rough. They give you like the minimum, but they don't think that it's something you need to integrate as a developer. So that could really use some love from most of the vendors, like to easily get updates, to have change logs and all that stuff that we're used to from more stable products. But again, this is something that will improve. And the same thing, with all the documentation. I didn't want to learn the internals of the SDKs, but for some reason I had to. We built the SDK in existing apps, which is an atypical use case from where you have the one app that does the video. So we hit things like memory leaks by closing the stream very often, the viewers. We had some players that would not block the sleep time, so it would kind of just fall into sleep mode after some time. So all these little things, just, again, it is just ramping up in the industry, but this was kind of the state that we experienced while doing TEF. In our use case, latency is important, but not always. It is far more important in most cases that everybody sees the same content at the same time. Because even if you're gambling or something, it might be delayed for 2-3 seconds, but if everybody sees it at the same time, it doesn't matter, the latency, as long as the latency is consistent over all devices. So that's something only, let's say 30% of the players are able to do. Most of them just focus on latency, but not on the synchronization. We had things happen that they say, well, build your own on top of the metadata. Well, if you don't have access to the frames, that's really annoying to do that. We can kind of speed up audio, but nobody wants to have speed up of audio. It's awkward if you do that stuff. So it's something that you want to look at there as well. And then as a bonus for the synchronization play, there are solutions out there that allow you to synchronize the video signal coming from television, and then obviously delay and synchronize it with the online signal, so everybody has the same latency, and it doesn't really matter whether they're participating on the TV on online. Obviously, there is still delay by the distributions, which are a little bit different, so you have to take that into account. But it is possible to have that synchronized as well. The one thing we found missing is that in our use case, people want to have our app sponsored by advertising. None of the players that we found had a solution that we would expect, like VPaid and Vast and whatever, to do that. So in one case, we even ended up to have like a traditional video player to play the ad and then switch over to the ultra-low latency player. So please, if you're building ultra-low latency or low latency, have a solution for that as well. It will save us the integration there as well. Another nice thing that we found is that a few of them, they will give you feedback when stream ends and so on, and are able to send that to you as feedback. So that's another feature that some of them have. And others, you just have to poll all the time to get the current state of the information. And then a third feature is more or less the Hangout feature. So what you're used to is having a group call or group chat or whatever. So it's not only the broadcaster, but that you can invite and have multiple streams at the same time being displayed. A use case could be is that you watch the live stream with your friends and you see the live feed of your friends as well when they react to something of somebody scored or something. So that's a feature which is useful. Or people being able to invite a guest on the show, which is from the audience sitting at home and getting called into the show by his stream. So it's a few use cases as a feature that you could do. Another feature that only a few had was stream protection. So they would just send out the stream, but if anybody guessed the endpoint and had the player, they would just be able to play that stream. I'm not even talking about DRM, which none of the solutions have on the low latency solution. But it's just like I can authenticate myself who has access to a stream, and then you can validate who will be able to watch the stream. So another feature to watch out in your selection process of ultra-low latency. And then something you would expect, redundancy, having an RTMP injet in multiple regions, having failovers. However, we did have experienced an interesting thing is that we had two encoders streaming active to the ingest points. They were totally separated, but and the stream had like synchronization enabled, so people would watch it at the same time. But because people were hitting two different streams, some would have synchronized on this one, and some would have been synchronized on that one. So we switched to active-passive on the selection on the client side, even though it was active-active on the server side. So another thing related to the synchronization. For us, as somebody building on top of the low latency platform, we currently have no way of load testing anything and knowing whether it will work at scale. We just have to believe you, in a way. With HLS, at least there were some tools and so on, but now we go live and we hope that the provider will be actually to be able to do it. So it's something I would like to have in a way to at least see how things are working out, or I can stress it together with the stress test of my app and see how that's working together. So all these solutions, they have like a cost structure. Some would have you pay for the player, iOS, Android, and so on, a license. Some would charge you for ingest minutes. Most of them would just charge you by gigabytes being played in the streamer, like you would have in a traditional streamer. But some of them went to a new model, which is viewing minutes. And the reason why that's became like a discussion point is that when you go to a customer and says, well, we have a show, we need a budget. Okay, do you know how many gigabytes you will have? And he goes like blank. Obviously, he doesn't know. It's a new audience, it's a new show, they don't know. And what we found is that it was way better to ask them, okay, how many users do you expect? And they say, well, they always pick the big numbers because they want to have a real success. So they say like, okay, 15,000, yes. And then you ask them, how long will they watch the show? Will they be 50% of the show and so on? So for them, it became way easier to calculate the cost that way because those were two metrics that they could understand, and the gigabytes just went blank for them. So it's something we see, especially for the shows who are like 10 minutes every day, an easier metric to be a cost model than the other part. So this was all like theory, research, and so on. And then we did like a soft launch and so on. But this is, obviously what reality looks like in production. So people started complaining, we don't see any video, the video freezes, there's pulsing audio, we have lip sync problems, and so on. So, everything we experienced in the past, nothing is new there. So time to investigate has been mentioned in the talk before. Network ports, some solutions rely on UDP, and it's sometimes funny, you have to sell it to a broadcaster, and they have this ultra-protected network, and the one thing they cannot do is watch their own stream, and everybody outside on mobile can watch it. So it's kind of, and then you have to talk to the corporate security team to open up ports. It should be all over HTTP port, whatever you stream on top of that, because if it's a WebSocket, you have a bidirectional, at least something that could go through most of the firewalls. And obviously proxies at providers. So because they're so proprietary protocol, watch out like what they actually do in real life conditions with that stuff. Then most of them support multiple bitrate fallback, although we found a few that always want to go with the highest one. So you see good, drop, good, drop. So obviously that's not good, but it's not always the case that it is a bandwidth issue. What we found that it was actually a CPU usage problem. So nobody tells you on the power that you really need to decode that in with their custom protocol in real time. And even though everybody had bandwidth, it tried to go up, but it just couldn't display. So something you need to be aware of, really testing it with like low, like even, let's say devices from last year, we were starting seeing, depending on the provider, problems with that as well. So it's far from the reality of 2 seconds delay and so on. This is what happens in real life. A show of 10 minutes drained an iPhone for 90%. Nobody told you what the mechanism was, but something that obviously the user starts complaining about, like, hey, my battery drain. Again, something we heard before, when YouTube changed their streaming, battery drain, and so on. Then coming back from foreground and background on your phone, bad connection, yeah, I'll try again. But because of the latency, it takes like 2-3 seconds to do that, and then it has to sync, so it takes a while for the stream to be seen again. So they would go like pop, 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 and it just like wouldn't show. So it's one of the things we hit there. And only a few of them we found actually expose the session ID of a user. So most of them would just say, well, OK, you connected, that's well. But what was really important is that we learned that when users start complaining about their connection, is that you have a streaming session that you can send to your provider for debugging. Otherwise, they will just get, OK, yeah, but we can't see really a generic issue with our platform. But if you give them 20 cases, like in this case, in this case, in this case, with this streaming ID, something went wrong, they have way more information. So you will provide them with device IDs, device types, network quality, the carrier they use, all the metadata to make a better case to do that. Sorry. And that brings the second part is that with their proprietary protocols, it's currently really hard to detect whether their stream is actually working. So it is really hard to integrate a player and then have that put know that the image is there, everything there. So you kind of are a little bit in the dark to know whether it's actually playing, whether it is doing that. It could be, detecting the offset, audio failure, all that stuff. So again, we're in a moment where we need to get better, and it's emerging, but it isn't there yet. So giving all these problems, the part of the solution is quite simple. Every time you hit a problem in the app, you say it's the network, and you put like visual indicators. There's a problem with your network. Get on better Wi-Fi. Get on better something else. But if the customer just sees a black screen, he thinks it's broken. He will try and try again. So really, I can't overstate this. Like put spinners, put feedback, whatever. If something's happening, it might not even be the network, but at least tell him that something has failed there as well. And then in my ideal world, whatever service is providing the low latency streaming, me, as a company that builds on top of that, I would really like to get your detailed metrics as well. And not only status green, red, and everything's OK. I want to see, like, hey, what's the lag that you're experiencing over your viewers and all that stuff. Because if we build on top of that, the customer will come to us, and we are responsible. And we need that data to be able to react and analyze at the first level to do that. And then whatever provider you pick, try to use somebody who has a decent escalation procedure and not say, just send us an email, or you can call number blah, and then it gets into a ticket. If you're doing live streaming, you just need better and faster support. Otherwise, the moment will be over, and you need to have a way more direct line. And this is basically what happens. You start debugging and so on. And if you're a company that doesn't allow me direct access to your engineers in some way to solve these problems, and it just has to go through account managers and so on, it's just too slow for me as a company building on top of that to do that. So the talk today might not have been like, hey, this is the best latency solution and so on. I just wanted to give you like the broad spectrum of things you will be hitting at today using any of the providers and things to look for beyond latency. And I do believe they will solve that. I will be making a list of things which I casually now told you, like, hey, this is something to look out for, like more of a checklist that you can find. If you're a provider, come talk to me. We can kind of see what model you have, what options you have to kind of benchmark you against the others. If you're interested in the research, just shoot me an email as well, patrick@zender.tv. But I do believe that it's going to happen with the 5G and so on. But today, it's still like, OK, so that was my talk.